In this video, we're going to be looking at one-sided derivatives. So when we've been using the difference quotient, remember, is a two-sided limit, which means that h is approaching 0 from both the left and the right side. And that can be a little bit confusing for students because we have to keep in mind the way we defined h when we set up our difference quotient is that h is the distance from our point of tangency to the made up point we're using so that we can find the slope. So h is a distance that we're saying approaches 0 from either the right side, in which case h would be positive, or from the left side of our point of tangency, in which case h is negative. Where this typically gets used, it can be used at endpoints of domains. However, a lot of times we're not really interested in the slopes at endpoints. However, we do use this a lot with piecewise functions where wherever two pieces of a function are meeting. So really all we're saying here is that if we're looking at a left-hand derivative, we're working out the slope to the left of the point that we're interested in. And a right-hand derivative, we're looking at the slope to the right of the point that we're interested in. So this makes a bit more sense with an actual example to look at. So here we have a piecewise function where our function is x squared when x is less than 0, and our function is 2x when x is greater than or equal to 0. And we want to find f prime of 0 if this exists. In other words, we want to know does the derivative or the slope of the tangent, slope of the curve, instantaneous rate of change exist at 0? So we can always start with our difference quotient. So the limit as h approaches 0, the two-sided limit as h approaches 0, of f of 0 plus h minus f of 0 all over h. Now in this case, we actually can say that what f of 0 is, because f of 0 is going to be 2 times 0, which is 0. And that's not going to change whether we approach from the left or the right, because when we're looking at f of 0, x equals 0. We're not approaching it. But when we look at f of 0 plus h, this depends on whether h is going to be positive, approaching 0 from the right, or negative, approaching 0 from the left. Because whether h is positive or negative affects which piece of our function we use for this value. So if we look at the left-hand derivative, in other words, I'm doing the limit as h approaches 0 from the left. Well, f of 0 plus h means I would use the first piece. F of 0 is always 0 for this function, all over h. Well, this would then, when I simplify, give me the limit as h approaches 0 from the left of h, which is 0. So to the left of my curve, the slope is 0. Or not to the left of my curve, to the left of x equals 0. The slope is 0. If I look going to the right-hand derivative, I'd be doing my limit as h approaches 0 from the right. Well, now f of 0 plus h, because h is positive, is going to use the 2x. F of 0 is still 0 because that doesn't matter where on h, that's dependent on 0. Well, this simplifies to the limit as h approaches 0 from the right of 2, which equals 2. So to the right of x equals 0, the slope is 2. Well, going way back to just, does a two-sided limit exist? Well, our left-hand derivative does not equal the right-hand derivative. So f prime of 0 does not exist. In other words, f is not differentiable. The derivative does not exist at x equals 0.